we're going to go through these practice problems as just additional practice for now that we've gone over notes for 1.2, evaluating limits graphically. So let me just kind of go through and review two items here. There is a distinction between function value and limit. So function value, such as f of -3, f of 3, and we're going to go down here, f of -3. These are just, we're just pinpointing the location of the graph. We don't care the behavior of the graph. We don't care about what's around that location. We just want to pinpoint the location of the graph. So that's function value. Now limit, we're more concerned about the movement towards that point rather than what's happening at that point. So we just want to know if we pick, if it's asking for a limit, we're going to follow the path of the graph. Are the two paths moving towards the same location? Are they converging towards the same location? It doesn't have to exist at that location, but as long as the movement is towards the same location, that's enough for our limit to exist. So I also want to kind of give you another visual that I thought of that may help. Think of this, imagine that we had a bird's eye view of these curvy roads, and we're looking down on these roads that cars are traveling on. And then let's say these holes represent roadblocks along these roads. Okay. So limit as x approaches -5 of f of x. So let's say we're our point is -5. So let's say we place two cars on either side of -5, relatively close to that -5, and then we're going to make these two cars drive along the path towards -5. Okay, so we're going to make this car drive towards. We're going to make it follow along the path of the roads. And then we're going to ask ourselves, are these two cars moving towards the same destination? Okay. And it's obvious that they're not moving towards the same destination. And if they're not, then the limit doesn't exist. Okay. Limit as x approaches -4. So again, we're going to pick 2 points on either side of -4. Let me see if I can find another. All right, so we're going to pick 2 points on either side of -4. So there's -4 here. I'll pick a point on one side of -4. I'll pick another point on the side of -4. And I'm going to make these two starting positions for these cars that I'm seeing. I'm going to make them move, follow the path of these roads. Okay. And are these two cars moving towards the same destination? Yes, right? They're both moving towards this hole, which is 1. So this is moving towards 1. That's also moving towards 1. Even though they may never reach it, they're both moving towards the same location, and that's enough for our limit to exist. Okay, so limit as x approaches -4. There's a consistent movement from both sides towards 1. Okay, f of -3. Now we're just looking for the point. We could care less what's happening around -3. We just want to know what's exactly happening at -3. And then -3, the graph goes right through that point, and that point is -2. Okay. All right, the limit as x approaches -3 of f of x. So again, I'm going to pick 2 points on either side of -3. And I'm going to make these 2 points move towards -3. So this is moving towards -3. This is also moving towards -3. And you see that they're both moving towards the same y value. They're both moving towards -2. So this is also -2. Now notice in this case, the order pair and the limit, they do agree. They're both the same value. And the reason why is because we have a connected part of graph. We have a continuous which we're going to talk about later, is a continuous graph. So there are no breaks, there are no vertical asymptotes, there are no holes. So if you don't see any breaks in the graph, then you should get order pair, function value, and limit to be one and the same. Okay. But if there's a break in the graph of any sort, then you're going to be expecting your function value and your limit to not be in agreement. Okay, let's look at f of 3. So f of 3, we just want to pinpoint, is the graph, does it exist anywhere at f of 3? So f of 3, there's a hole there, but there's no point that exists at 3, right? So here we say the function value does not exist. It's undefined. You can say undefined. You can say does not exist. Any variation of that is fine. Okay, so we try to pinpoint a location, and the location doesn't exist. There's a hole there, and there's no point that fills in anywhere else. So there's no f of 3. Now the limit as x approaches 3. So again, we're going to pick 2 points on either side of 3. Bird's eye view. We're looking at starting locations for these 2 cars. We're going to make the 2 cars move towards 3 and see, are these 2 cars moving towards the same destination? Even though there's a roadblock here, they're both moving towards the same destination. They're both going to end up at a y value of -3. So because there's a consistent movement towards the same location, even though that location doesn't exist, the approach is consistent. So we just want to know where it's approaching. They're both moving towards a y value of -3. Okay, again, limit as x approaches 6. So we find 6. We're going to put 2 points on either side of 6. And then we're going to make these 2 points move towards 6. So this is going to move towards 6. This is also going to move towards 6. But we see that these are obviously moving towards different destinations, right? Even though there's a point here, this is moving from this, if we're looking at it from this car's perspective, this car is moving towards -5. This car is moving towards 0, and they're not making their way towards the same destination, so therefore the limit does not exist. All right, let's look at number 8. Limit as x approaches -8. So I pinpoint -8. I'm going to pick 2 points on either side of -8. I'm going to make these 2 move towards -8. And they're both moving towards the same y value of 1. Okay. Oh, and also another thing, as you're picking points on either side, make it relatively close, right? I don't want to be picking a point here and a point here. That's too far away. I want to pick relatively close towards -8, preferably within 1 unit away. If I pick something that's too far away, then it's not within the same branch, and I'm not getting the behavior that I want. Okay. Limit as x approaches -7. So here's -7. We're going to pick points relatively close to -7 on either side of -7. And now I'm going to make these 2 points move towards -7. So this is moving towards 0. This is moving towards a different location, which is -4. 0 and -4. These 2 cars are not moving towards the same destination. So we're going to say that the limit doesn't exist. Okay, f of -3, we just want to pinpoint the location of the graph at -3. And at -3, there's a hole there. Nothing is defined here. But there is a point that is defined elsewhere. So we just want to know where that point is. That point is at -3. All right, y value. Function value and limit, we're always determining, it's going to be in terms of a y value. So -3. Okay. Limit as x approaches 4. So limit as x approaches 4. So there's 4. I'm going to pick 2 points on either side of 4, relatively close to 4. and I want to follow the path of the graph to see, are these two paths moving towards the same location? Even though there's a hole there, they're both moving towards the same hole. So this side is moving towards the hole, which is at -1. This side is also moving towards the same location. There's a consistent movement towards the same location, and the location that they're getting closer is -1. Now, f of 4 is something entirely different, because f of 4 is not talking about the hole. It's going to talk about where that point is located. So f of 4 is 1. Okay, so put a star next to 11 and 12, because it's these types of problems that give students the most trouble. I think the tendency is we want to pick out where that point is, and the pitfall is students want to see limits x approaches 4. Well, looks like it's going to be at 1, but that's not where the path of these graphs are moving, right? We want to follow where the path of the graph is moving. So that's the distinction between limit and function value. Function value, we just care about the point. Limit, we want to know where the path is moving towards. We want to follow the path of these graphs, follow the path of these roads, and see where the movement is headed towards. Okay. F of 6. F of 6, we want to pinpoint just that point here. Now, there's nothing that exists because there's a hole there. Do we see any other point on 6? There's nothing that's defined at 6. So we say the function value doesn't exist. Okay. Now, limit as x approaches 6. Okay. We have connected graphs on either side of 6. If I pick points on either side of 6 and I move towards 6, we see that there is a consistent movement towards the same destination, and that movement is towards y value of 1. So limit does exist at 1, even though the function value doesn't exist. Right, limit as x approaches 7. So here's 7. I'm going to find a point on the graph on either side of 7, relatively close to 7. And I'm going to make my way towards 7 along the path of the graph. So this is moving towards me towards a y value of 2. This is moving me towards a completely different y value of 7. So we see that there's no consistency. These two paths are not moving towards the same destination. So we say the limit doesn't exist.